Hello friends, today we are going to see another video on crashing of a project. The given data is as follows. We have all the activities, the normal time of each activity, the crash time, normal cost and crash cost. The indirect cost given is 2000 rupees per day. Now we need to find the optimum duration in which this project can be completed and the corresponding cost. From the given data, let's prepare the network diagram first. Activities are 1, 2, 1, 3. 1 will be the central node. This here will be the second node. Here will be the third node. Activity 1, 2 and 1, 3 is done. Next is 2, 4. 2, 4, 3, 5, 2, 5. Okay, 2, 4 will be here. 3, 5 and 2, 5. We'll just keep fifth node over here. And 2, 5 will go like this. Okay, 2, 4, 3, 5 and 2, 5 is also done. Next, 4, 6, 5, 6. 4, 6, 5, 6. We'll keep sixth node in the center. Okay, 4, 6 and 5, 6 is also done. Then we have 6, 7 and 5, 7. Okay, let's do like this. 6, 7, 5, 7. All the activities are covered. Now we'll just mention the normal time and crash time of each activity below the arrow. So for activity 1, 2, the normal time is 8, crash time is 4. I'll just mention it over here, 8, 4. Similarly for activity 1, 3, normal time is 5, crash time is 3. So I'll write over here 5, 3. Next for activity 2, 4, the durations are 9 and 6. 9, 6. Then for 3, 5, 7, 5. Then for activity 2, 5, it is 5, 1. Then again for activity 4, 6, it is 3, 2. Then for activity 5, 6, it is 6, 2. For activity 6, 7, it is 10, 7. 10, 7. For activity 5, 7, it is 9, 5. Okay, the network diagram is now complete. Now we need to find out the critical path and the total project duration. For that, we'll be listing out all the possible paths from the first activity to last activity. Let's start. The first path will be 1, 2, 4, 6, 7. Okay, I'll just write down over here all paths, normal time and crash time. The first possible path will be 1, 2, 4, 6, 7. 1, 2, 4, 6, 7. The normal time of that path will be 8 plus 9, 17, 17 plus 3, 20, 20 plus 10, 30. The crash duration for that path will be, now we'll be taking into consideration the time which is mentioned in the bracket. So the crash time for this path will be 4 plus 6, 10, 10 plus 2, 12, 12 plus 7, 19. First path is done. Now let's move on to the second path. The second possible path will be 1, 2, 5, 6, 7. 1, 2, 5, 6, 7. The normal time of this path will be 8 plus 5 13, 13 plus 6 19, 19 plus 10 29. Similarly, the crash duration for this path will be 4 plus 1 5, 5 plus 2 7, 7 plus 7 14. Let's move on to the third path. Third path will be 1 2 5 7. 1 2 5 7. The normal duration for this path will be 8 plus 5 13, 13 plus 9 22. And the crash duration will be 4 plus 1 5, 5 plus 5 10. Okay, let's move on to the next path. The next path will be 1 3 5 6 7. 1 3 5 6 7. The normal duration for this path will be 5 plus 7 12, 12 plus 6 18, 18 plus 10 28. The crash duration for this path will be 3 plus 5 8, 8 plus 2 10, 10 plus 7 17. Let's move on to the next possible path. The next possible path will be 1 3 5 7. 1 3 5 7. The normal duration of this path will be 5 plus 7 12, 12 plus 9 21. The crash duration will be 3 plus 5 8, 8 plus 5 13. Okay, now we have all the possible paths, normal duration of each path and crash duration of each path. Which path is having maximum normal duration? 30 days of first path. 30 days. So this is our critical path, path 1 2 4 6 7. I'll just highlight it in the network diagram. 1 2 4 6 7. Okay, it is having maximum normal duration, so this path is the critical path. The maximum crash duration is of the same path, 19 days. Please remember, it is not at all necessary that the path having maximum normal duration must have maximum crash duration. Crash duration can be maximum of any of the following paths. These two values say that our crashing process will start from 30 days and it will stop at 19 days, because there is no way this project can be completed in less than 19 days. Okay, we have the network diagram, we have the all possible paths, and we have the critical path. Now we need to calculate the total cost of the project. The total cost of the project is calculated by using the formula total cost summation of normal cost plus project duration or project time into indirect cost per day. Summation of all normal cost means we'll be adding these costs, normal cost. So 3000 plus 4000, 7000, 7 plus 4000, 11,000, 11,000 plus 2000, 13,000, 13,000 plus 8,000, 21,000, 21,000 plus 10,000, 31,000, 31,000 plus 4,000, 35,000, 35,000 plus 6,000, 41,000, 41,000 plus 4,200 gives 45,200. So our total normal cost is 45,200 plus project time, maximum time is 30. So here project time will be 30 into indirect cost per day. Indirect cost per day is given in the given data. which is 2000 rupees. So plus 30 into 2000, which gives 45,200 plus 60,000, which means our total project cost is 1,05,200. This is our total project cost. Okay. Now the next step is we need to calculate the cost slope of each and every activity. The cost slope can be calculated by using the formula cost slope is equal to crash cost minus normal cost divided by normal duration minus crash duration. Crash cost minus normal cost divided by normal duration minus crash duration. By using this formula, we'll be calculating the cost slope of all the activities. So the cost slope of first activity will be 6,000 minus 3,000, which gives 3,000 divided by 8 minus 4 is 4. So 3,000 divided by 4, the cost slope of first activity will be 750 rupees. 750. Similarly, the cost slope of second activity will be 8,000 minus 4,000 gives 4,000. 4,000 divided by 5 minus 3 is 2. So 4,000 divided by 2, the cost slope will be 2,000. Next step is 5,500 minus 4,000, which gives 1,500. 1,500 divided by 9 minus 6 is 3. So 1,500 divided by 3, the cost slope is 500. Next activity, 3,200 divided by 2,000 gives 1,200. 1,200 divided by 7 minus 5 is 2. 1,200 divided by 2, the cost slope is 600. For next activity, 12,000 minus 8,000, 4,000. 4,000 divided by 5 minus 1 is 4. 4,000 divided by 4, the cost slope gives 100. The cost slope will be 1,000. Next is 11,200 minus 10,000, which again gives 1,200. 1,200 divided by 3 minus 2 is 1. So the cost slope will be 1,200. Next is 6,800 minus 4,000, which gives 2,800 divided by 6 minus 2 is 4. 2,800 divided by 4, the cost slope will be 700. Next is 8,700 minus 6,000 divided by 10 minus 7. 2,700 divided by 10 minus 7 is 3. So the cost slope here will be 900. Next step is 9,000 divided by 4,200, which is 4,800. 4,800 divided by 9 minus 5 is 4. 4,800 divided by 4, the answer is 1,200. Okay. We have the network diagram, we have the critical path, we have total project duration, we have cost slope of each and every activity. So now we can start with the crashing process. The rule of the crashing is we have to crash that activity on the critical path first, which has the least cost slope. Okay, so let's move towards crashing. Okay, so our first step of crashing will begin now. Now let's see which activity on the critical path has the least cost slope. Activity 1-2 has cost slope of 750. Activity 2-4 is having cost slope of 500. Activity 4-6 is having cost slope of 1,200. Activity 6-7 is having cost slope of 900. So the minimum cost slope is 500, which is of activity 2-4. So our first step of crashing will be crashing activity 2-4 by 1 day. Crashing 2-4 by 1 day. Now the total duration here was 30 days. Now it will be reduced by 1 day because we have crashed activity 2-4 by 1 day. So the time will now be 29 days. And the corresponding cost will be Total cost of the project is 1,05,200, which we calculated in the earlier step. 1,05,200 plus cost slope of activity 2.4 is 500. Okay, 500 minus indirect cost of 1 day, which is 2,000. The cost was reduced by 1 day, so the indirect cost of 1 day will be subtracted, which is 2,000 rupees. Now here we get the cost as 1,03,700. Okay, at first the cost was 1,05,200. After crashing activity 2.4 by 1 day, the cost was reduced to 1,03,700. Activity 2.4 was crashed, so we'll be updating it in the network diagram. Now here the normal duration was 9. As the activity was crashed by 1 day, here it will be 8. Okay, and activity 2.4 comes in which of the following paths? In first path, yes it does. So here 30 will now become 29. In second path, 2.4 does not come. Third path also 2.4 does not come. Fourth path also doesn't have activity 2.4, and the last path also doesn't have activity 2.4. Now if you see the first path and the second path, they are having same normal durations, 29 days. Now it means that there are two critical paths, first path and the second path. I'll just mention it in the second step of crashing now. There are two critical paths. We'll list out both the paths. First path is 1, 2, 4, 6, 7. Second path is 1, 2, 5, 6, 7. We'll list out the independent activities of both the paths. So for first path, the activities will be 1 to 2, 2 to 4, 4 to 6, 6 to 7. And for second path, the activities will be 1 to 2, 2 to 5, 5 to 6, 6 to 7. Okay. Now let's check if these two paths have any common activities. Activity 1, 2 is common, so we'll just strike it once and I'll write it over here. Activity 1, 2. What is the cost slope of activity 1, 2? Cost slope of activity 1, 2 is 750. 750. Are there any more common activities? Yes. Activity 6, 7 is also common in both paths, so I'll strike that activity once. What is the cost slope of activity 6, 7? Cost slope of activity 6, 7 is 900. Now there are no more common activities in these two paths. Now we'll be making the combinations. The combinations should be such that one activity from each path must be selected and no activity must be repeated. So the first combination will be 2, 4 plus 2, 5. First activity from first path plus first activity from second path. Okay. Second combination will be 2, 4 plus 5, 6. First activity from first path plus second activity from second path. Okay. What is the cost slope of 2, 4? Cost slope of 2, 4 is 500. 500 plus cost slope of 2, 5. 2, 5 is 1000. 500 plus 1000, the combined cost slope is 1500. Again here, cost slope of 2, 4 is 500 plus cost slope of 5, 6 is 700. 700 plus 500, we get 1200 combined cost slope. Now the next combinations will be 4, 6 plus 2, 5. Second activity from first path plus first activity from second path. And again next combination 4, 6 plus 5, 6. Second activity from first path plus second activity from second path. Now the cost slope of 4, 6 is 1200. 1200 plus cost slope of 2, 5 is 1000. So the total combined cost slope will be 2200. Again cost slope of 4, 6 is 1200. Cost slope of 5, 6 is 700. So the combined cost slope will be 1900. Out of these listed combinations, which is having the least cost slope. The cost slope is least of 1 2 750 only, and it is also a common activity in both paths. So in second step of crashing, we'll be crashing activity 1 2 by 1 day. Now the time will again be reduced. In first step of crashing, the time was 29 days. Now it will be 28 days. And the corresponding cost will be total cost plus crash cost minus indirect cost of 1 day. So the total cost will now be 1,03,700, which we got in the first step of crashing. 1,03,700 plus cost slope of 1 2 is 750 plus 750 minus indirect cost of 1 day is 2,000. Now here we get the answer as 1,02,450. Okay, again the cost was reduced from 1,03,700 to 1,02,450. The duration was also reduced by 1 day. Activity 1 2 was crashed. We'll just update it in the network diagram. 1 2 has normal duration of 8. Now it will become 7 because the activity was crashed by 1 day. Now we'll also update the table of where all the paths are mentioned. 1 2 comes in the first path. Yes, it does. Here it will be reduced by 1 day, so 29 will become 28. 1 2 also comes in the second path. Again 29 will become 28. 1 2 activity also comes in the third path, so 22 will now become 21. 1 2 does not come in the fourth path. It also does not come in the last path. So these durations will now be unchanged. Okay. Now if you see, this path is also having 28 days duration. First is having 28 days, second is having 28 days. Now third will also have 28 days. So which means that there are 3 critical paths now. Okay. Third step of crashing, there are 3 critical paths. The first path is 1 2 4 6 7. The second path is 1 2 5 6 7. And the third path is 1 3 5 6 7. 1 3 5 6 7. We'll write down the independent activities of each path. 1 2 2 4 4 6 6 7. Again 1 2 2 5 5 6 6 7. For the last path 1 3 3 5 5 6 6 7. So is there any common activity in these 3 paths? Yes, activity 6 7 is common. So we'll just write it once. The cost slope of activity 6 7 is 900. We'll write it down over here. 6 7 is 900. Are there any more common activities in these 3 paths? 1 2 2 4 4 6, 1 2 2 5 5 6, 1 3 3 5 5 6. So there are no more activities which are common in these 3 paths. As there are no more common activities, now we'll be making the combinations. Now the first combination will be first activity from first path, first activity from second path, first activity from third path. Here the activities are 1 2, 1 2 and 1 3. But the rule of making combinations say that one activity from each path must be selected and no activity must be repeated in a combination. So here if you see, activity 1 2 will be repeated, right? So we'll just mention 1 2 only once plus 1 3. Understood? The combination was 1 2 plus 1 2 plus 1 3, but 1 2 was repeated. So we'll take 1 2 only once, 1 2 plus 1 3. Okay, cost slope of 1 2 is 750 and cost slope of 1 3 is 2000. So the total combined cost slope will be 2750. Okay. Our next combination will be first activity from first path, first activity from second path, second activity from third path. So now it will be 1 2 plus 1 2 plus 3 5, but again 1 2 is repeated, so we'll take 1 2 only once and then we'll take 3 5. Cost slope of 1 2 is 750 and cost slope of 3 5 is 600. So the combined cost slope here will be 1350. Our third combination will be first activity from first path, first activity from second path, third activity from third path. But again 1 2 will be repeated, so we'll take 1 2 only once and then the third activity from third path is 5 6. Cost slope of 1 2 is 750 plus cost slope of 5 6 is 700. 750 plus 700, we get the combined cost slope as 1450. Okay, now we'll proceed to the next set of combinations. Now what we'll do, we'll take first activity from first path, second activity from second path, first activity from first path. So again 1 2 plus 2 5 plus 1 3. Cost slope of 1 2 is 750. Cost slope of 2 5 is 1000. Cost slope of 1 3 is 2000. Here we get the combined cost slope as 3750. Now the next combination will be first activity from first path, second activity from second path, second activity from third path. So these two will remain same, that is 1 2 plus 2 5 will be same. Third activity will be 3 5, which is second activity from third path. 3 5. Again the cost slope will be 750 plus 1000. Cost slope of 3 5 is 600. So 750 plus 1000 plus 600, we get the cost slope as 2350. Now the next combination will be, these two will again be same, 1 2 plus 2 5. Now we'll take third activity from third path. 1 3 was taken here, 3 5 was taken here. Now 5 6 will be taken over here. So 1 2 plus 2 5 plus 5 6. So it will be 750 plus 1000 plus cost slope of 5 6 is 700. So 750 plus 1000 plus 700. Here we get the combined cost slope as 2450. Okay. Now our next set of combination will be first activity from first path, third activity from third path, first activity from third path. I'll repeat again, first activity from first path, third activity from second path, and first activity from last path. Okay, again 1 2 plus 5 6 plus 1 3. The cost slope of 1 2 is 750, cost slope of 5 6 is 700, and cost slope of 1 3 is 2000. 750 plus 700 plus 2000, the combined cost slope is 3450. Now the next combination will be 1 2 and 5 6 will remain same. First activity from first path, third activity from second path. Now here we'll take second activity. 1 3 was taken here. In next combination we'll be taking 3 5. Cost slope of 1 2 is 750. Cost slope of 5 6 is 700. Cost slope of 3 5 is 600. 750 plus 700 plus 600, we get the combined cost slope as 2050. Next is again first two activities will be same, 1 2 plus 5 6. Now here after 3 5 there is activity 5 6, but in second path from we already got 5 6, so 5 6 will not be, we cannot repeat over here. So third combination will be 1 2 plus 5 6. Cost slope of 1 2 is 750. Okay, cost slope of 5 6 is 700. Seven 50 plus 700, we get the combined cost slope as 1450. Okay, this part is a bit confusing. I'll repeat again how we made these combinations. First what we did, first activity from first path, first activity from second path, first activity from third path. But here activity 1 2 was repeated, so we took it only once, and first activity from third path was 1 3. Similarly, first activity from second path, from first path, first activity from second path, second activity from first path. Again 1 2 was repeated, we took it only once, and second activity was 3 5. In this way we made all the combinations. Now the next set of combinations, in first set we got 1 2 3 4 5 6 7 8 9. Okay, in second set of combinations we'll be also getting 9 combinations. In third set also we'll be getting 9 combinations. Now if you pay attention, the first activity of from first path, it was repeated over here 9 times in a row. The second activities were 1 3 3 5 5 6. The second activity is also 1 2, so it was not repeated. Here if you see 2 5 2 5 2 5, second activity. Third activity was 5 6 5 6 5 6. Similarly, in case of last activity 1 3 3 5 5 6, they were repeating in set 1 3 3 5 5 6, 1 3 3 5 5 6, 1 3 3 5 5 6. Here 5 6 was not taken because the second activity was already 5 6 from second path. Now we'll move on to the next set of combinations. In the next set of combinations we'll be making the combination in this way. We'll be repeating the activities and we'll be just adding them. Okay, so for the next set of combinations, for in this set we took first activity from first path. In first set of combinations we took first activity from first path. Now we'll be taking first activity from second path, which is 2 4. 2 4. Now if you see over here 1 2 was repeated 9 times. Here also we'll write down 2 4 9 times. 2 4 plus, because there will be more activities. This will be second time, this will be third time, this will be fourth time, this will be fifth time, sixth, seventh, eighth, ninth. Okay, 9 times we have written the second activity from first path. Now these activities 1 2 2 5 and 5 6, they will be repeating in a set of 3. See over here 2 5 was thrice, 5 6 here was thrice. Here 1 2 should have been thrice, but it was repeated again, so 1 2 was not taken. So we'll just mention each activity in set of 3. Okay, so the first will be 1 2. 1 2 will be written thrice. 1 2 plus 1 2 plus 1 2 plus. Now next will be 2 5. 2 5 will be written thrice. 2 5 plus 2 5 plus 2 5 plus. Last activity is 5 6. Now 5 6 will be written thrice. 5 6 plus 5 6 plus 5 6 plus. Now in third row, if you see over here the activities from last path, which are 1 3 3 5 5 6, they were in repetition. 1 3 3 5 5 6. Here also 1 3 3 5 5 6. here 1 3 3 5 5 6, but 5 6 was repeated, so it was eliminated. Okay, again now we'll be writing 1 3 3 5 5 6 serially. 1 3 3 5 5 6, again 1 3 3 5 5 6, again 1 3 3 5 5 6. Okay, now let's say that the second set of combinations is now ready. Now we have to mention the cost slope of these combinations and we have to add them. So the cost slope of activity 2 4, cost slope of activity 2 4 is 500. We have to refer the first table for that. Cost slope of activity 2 4 is 500. So now we'll write 500 plus cost slope of activity 1 2 is 750. 500 plus 750. For activity 1 3 it is 2000. 2000. So 2000 plus 750 plus 500, we get the combined cost slope as 3250. Now again 500 of 2 4, for 1 2 again 750. The cost slope of activity 3 5 is 600. 750 plus 600 plus 500, we get the cost slope as 1850. Again 500 plus 750, cost slope of 5 6 is 700. 500 plus 750 plus 700, we get the cost slope as 1950. Again cost slope of 2 4 is 500 plus now 2 5, cost slope of 2 5 is 1000. 500 plus 1000. Now these two values 500 plus 1000 will be repeated 3 times. See over here 500 750 was repeated 3 times, and now again these values will be repeated. 2000, 500 plus 1000 plus 2000, the cost slope will be 3500. Again the repetition will be 500 plus 1000, after 2000 there is 600. Okay, 500 plus 1000 plus 600, the cost slope will be 2100. Again 500 plus 1000 plus 700, the cost slope will be 2200. Here cost slope of 2 4 is again 500. I'll just write 500 500 500 plus plus plus. Cost slope of 5 6 is 700. 700 700 700. Now again 1 3 3 5 5 6, 2600 700, 2600. Now here 700 will not be repeated because 5 6 will be taken only once. Okay, here we'll write it directly. So 500 plus 700 plus 2000 will get as 3200. Then again 500 plus 700 plus 600 we get as 1800. Then 500 plus 700 we get 1200. Here I have written 5 6 again, but I have cancelled it and taken only cost of 2 4 and 5 6 because 5 6 cannot be repeated. So 500 plus 700 is 1200. Our second set of combinations is ready. Now we'll be moving towards the third set of combinations. Now our third set of combinations, set of 1 2 is over here, set of 2 4 is over here. Now we'll be making set of 4 6, which is third activity from first path. So again I'll just write down 4 6 9 times, because for every set we are getting 9 combinations. Now again, for second values, if you see over here, 3, 3, 3. 3 sets are repeated of 1, 2, 2, 5 and 5, 6. Same way we'll do it over here. 1, 2 plus 1, 2 plus 3 sets of each activity. 3 of 1, 2 is done. Now we'll do of 2, 5. 2, 5, 2, 5, 2, 5. Last will be of 5, 6. 5, 6, 5, 6, 5, 6. Now again, of last path, set of 3 will be repeated. 1, 3, 3, 5, 5, 6. 1, 3, 3, 5, 5, 6. Will you repeat it? Okay. Again, 1, 3, 3, 5, 5, 6. Again, 1, 3, 3, 5, 5, 6. For the last time, 1, 3, 3, 5, 5, 6. But here 5, 6 will be repeated. So we'll strike it once. We will not take the third one into consideration. Now what is the cost slope of 4, 6? If you see to the table, cost slope of 4, 6 is 1200. Again 1200 will be writing 9 times. Okay, now 1, 2, 2, 5 and 5, 6. Cost slope of 1, 2 is 750. We'll be writing it 3 times. 3 times 1, 2 we have mentioned. Now cost slope of 2, 5 is 1000. Again we'll be writing 1000 3 times. 1000 is written 3 times. Now cost slope of 5, 6. Cost slope of 5, 6 is 700. That also we'll mention 3 times. Okay. Here we have only 2 values, so we can directly write is equal to. Now again 1, 3, 3, 5, 5, 6. If you see over here, 1, 3, 3, 5, 5, 6. Cost slopes are 2600 and 700. Again 2600, 700. Again 2600, 700. Again 2600. Here 700 will not be written because it will be repeated. 5, 6, cost slope of 5, 6 will only be written once. Okay. Now we'll just add the values. 1200 plus 750 plus 2000. Here we get the cost slope as 3950. In second step, 1200 plus 750 plus 600, we get the cost slope as 2550. In third step, 1200 plus 750 plus 700, we get the cost slope as 2650. In this step, 1200 plus 1000 plus 2000, here we get the cost slope as 4200. In next step, 1200 plus 1000 plus 600, we get the cost slope as 2800. In next step, 1200 plus 1000 plus 700, we get the cost slope as 2900. In next step, 1200 plus 700 plus 2000, we get the cost slope as 3900. Again 1200 plus 700 plus 600, we get the cost slope as 2500. Now over here 1200 plus 700, we get the cost slope as 1900. Now we can say for our third step of crashing, we have all the combinations. Okay. Now let's see which combination has the least cost slope. The answer is very simple. The common activity which is activity 6.7, is having the least cost slope, which is of 900. So in third step of crashing, we will be crashing activity 6.7 by 1 day. The time will now be, in second step of crashing, the time was 28 days. So now the time will be 27 days. And the corresponding cost will be, total cost will now be the cost which we got in second step, which is 1,02,450 plus cost slope of 6.7 is 900 minus indirect cost of 1 day is 2,000. Okay, so here we get the answer as 1,01,350. Okay, again the cost was reduced from 1,02,450 to 1,01,350. Activity 6.7 was crashed, right? Activity 6.7 was crashed by 1 day. We'll be updating it in the network diagram. 6.7, normal deviation was 10, now it will become 9. Okay, 6.7 comes in which path? In first path, yes it does. So 28 will now become 27. Second path also it comes, 28 will become 27. Third path it does not come. In fourth path, yes, 28 will again become 27. Again we have 3 critical paths. Now if you see, for third step of crashing, the lengthy combinations which we made, third step of crashing starts over here, ends over here. So we made these combinations. Least combination was of common activity 6.7. Okay, now you people will say that making these combinations was waste of time, because for first set, first activity was 1 2, cost slope was 750. So whatever combinations we make over here, it will be greater than 750 but maybe less than 900. So making first set was okay, making second set was also okay because it was greater than 500, but maybe we can get less than 900. But in third case, the starting was itself was 1200. So you people may say that making the third combination was useless, but please remember one thing, making these combinations will be helpful for us in our next step of crashing. As we proceed, you'll realize it how. Okay, in third step of crashing, activity 6.7 was crashed. But if you see in the network diagram, there is still scope for crashing activity 6.7. Okay, it can be crashed up to 7 days. We have crashed it only once, so the duration is now 9 days. There is a scope for crashing, and while crashing in third step, no activity was exhausted and no new critical path is added. Okay, the critical paths are again same, 27, 27, 27. 3 paths are same. So here we'll crash activity 6.7 again. In fourth step of crashing, we'll crash 6.7 again by 1 day. Time in third step was 27 days, now it will be 26 days. Okay, so here the corresponding cost will be, total cost will now be 1,01,350 plus cost slope of 6.7 is 900 minus indirect cost is 2,000. So here we get the answer as 1,02,50. 1,02,50. Again the cost was reduced from 1,0350 to 1,02,50 and time was reduced to 26 days. Activity 6.7 was crashed again. Okay, so we update it in the network diagram. Here it was 9, now it will become 8. 6.7 comes in the first path, yes, 27 will become 26. Second path also it comes, again 27 will become 26. Third path it does not come. In fourth path again 27 will become 26. Again the same thing, no new critical path is added, no activity was exhausted in fourth step of crashing. and there is still scope for crashing activity 6 7. Okay, so again in fifth step of crashing, we'll be crashing activity 6 7 again by 1 day. Crashing activity 6 7 again by 1 day. Now the time will become, first it was 26, now it will become 25 days. Now the corresponding cost will be, total cost will now be 1,02,50 plus cost slope of 6 7 is 900 and indirect cost is 2000. So 1,02,50 plus 900 minus 2000, we get the cost as 99,150. Again the cost was reduced. Activity 6 7 was crashed, so we'll update it in the network diagram. 6 7 was crashed. Now normal time is 7, crash time is also 7. Activity 6 7 is now exhausted. Okay, here activity 6 7 comes in the first path, yes, 25. In second path also, here it will be 25. In third path it does not come. In fourth part, yes, here it will be 25. Okay, now crashing step number 6. Sixth step of crashing, and activity 6 7 is exhausted because it cannot be crashed further. 6 7 cannot be crashed further. Now again the critical paths are same, right? The critical paths are still same. These three paths are the critical paths, and the activity was exhausted, which was 6 7, but again 6 7 was a common activity, right? 6 7 is exhausted, but 6 7 was a common activity. It wasn't a part of any of these combinations. Okay, 6 7 is out of the picture. 6 7 is out of the picture. So now which combination is having the least cost slope? We'll be checking that one. Okay, 6 7 is out of the picture. Now which combination is having the least cost slope? Now if you see, in first set the least cost slope is of this, which is 1350. In second set the least cost slope is of 1200, and in third step the least cost slope is of 1900. So by default in all three sets the least is of 1200. Understood? Pay attention. The critical paths are still same, right? Even though activity 6 7 is out of the picture, only this combination will be out of the picture, and there is no point in making the combinations again because no new critical path is added. If, let's say for example, activity 2 5 was exhausted, then there was a need to make new combinations again, but here only the common activity is exhausted, rest all is same. So next least cost slope is of this combination, activity 2 4 and 5 6. Okay, so in sixth step of crashing, we'll be crashing activity 2 4 and 5 6 by 1 day. Crashing 2 4 and 5 6 by 1 day. The time was 25 days in last step. Now the time will be 24 days. And the corresponding cost will be, total cost will now be here 99,150, which we got in last step. 99,150 plus combined cost slope of 2 4 and 5 6. 2 4 and 5 6 is 1200 plus 1200 minus 2000. Okay, so here we get the answer as 98,350. 98,350. Again the cost is reduced. Okay, now activity 2 4 and 5 6. 2 4 and 5 6 was crashed. We'll be updating it in the network diagram. 2 4 8 will now become 7. and in case of 5 6, 6 will now become 5. Now activity 2 4 or 5 6 comes in which of the following paths? In first path, activity 2 4 is present, 25 will become 24. In second path, activity 5 6 is present, 25 will become 24. In third path, 2 4 is not present, 5 6 is also not present. In fourth path, 5 6 is present, so 25 will become 24. In last path, 2 4 is also not present, 5 6 is also not present. Okay. Now again, if you see, no activity is exhausted, no new critical path is introduced, and still there is a scope for crashing 2 4 and 5 6 as well. So we'll be repeating that step again. So in 7th step of crashing, this was 6th step, 7th step of crashing, we'll be crashing activity 2 4 and 5 6 again, crashing 2 4 and 5 6 by 1 day. Now the time will be reduced by 1 day, so 24 will become 23 days, and the corresponding cost will be 98,350 is the total cost which we got in the last step, plus combined cost slope is 1200. Cost slope of 2 4 and 5 6 is 1200, minus indirect cost of 1 day is 2000. Here we get the answer as 97,550. Again the cost is reduced. Now again activity 2 4 and 5 6 was crashed. We'll update it in the network diagram. 2 4 7 will now become 6. Normal time and crash time is now same, so now activity 2 4 will be out of the picture. 5 6 was also crashed, so 5 will become 4. Here the table will also be updated now. Okay, activity 2 4 and 5 6 was crashed. 2 4 comes in the first path, yes. 2 4 or 5 6 comes in the second path, yes. In third path it does not come. In fourth path 5 6 is present, so this will also become 23. Okay, so now in 8th step of crashing, activity 2 4 is exhausted now. I'll just mention over here 2 4 cannot be crashed further. Okay, now again the critical paths are same, right? The three critical paths are same, only activity 6 7 and activity 2 4 are out of the picture. 6 7 and 2 4 are out of the picture. Now if you see the combinations of the third step of crashing, after removing 2 4 and 6 7, see these are all the combinations of third step. Okay, 2 4 is not to be considered now, which is out of the picture. Okay, 6 7 is already out of the picture. Now again these combinations will be out of the picture. Second set will be out of the picture. Now from third set and this one, first set, which is having the least cost slope, which combination is having the least cost slope, we'll see that. Now if you see activity 1 2 and 3 5, here it is 1350, which is least from the first set, and from the last set least one is 1900. Obviously 1350 is lower, so our next step of crashing will be crashing this, will be crashing activity 1 2 and 3 5. Okay, 2 4 is out of the picture now, 6 7 is already out of the picture, so we neglected the combinations of this 2 4. This is the set of 2 4, this set was neglected. From 4 6 and from the set of 1 2, we are taking the least combinations, which is 1350. Okay, so in next step of crashing, which is the 8th step, we will be crashing activity 1, 2 and activity 3, 5. Activity 1, 2 and 3, 5 will be crashed now. I hope this is clear. Okay, activity 1, 2 and 3, 5 is having the least cost loop of 1350. Okay, so crashing activity 1, 2 and 3, 5 by 1 day. Now the time will be reduced from 23 days to 22 days, and the corresponding cost will be 97,550 plus combined cost loop is 1350 now of 1, 2 and 3, 5. 1350 minus 2000. Here we get the answer as 96,900. Again the cost is reduced. Activity 1, 2 and 3, 5 was crashed. Okay, we'll update it in the network diagram. 1, 2, here it is 7, now it will become 6, and for 3, 5 over here 7 will now become 6. Now again if you see, 6, 7 is out of the picture, 2, 4 is out of the picture, 1, 2 and 3, 5 was crashed, no new critical path is introduced. Again if we update the table, you would notice that 1, 2 and 3, 5 was crashed. So 1, 2 is over here, 23 will become 22. 1, 2 is over here, 23 will become 22. In third path also 1, 2 is there, 21 will become 20. In this path 3, 5 is there, 23 will become 22. In this path also 3, 5 is there, 21 will become 20. Again 22, 22, 22. Critical path is same. There is still scope for crashing activity 1, 2 and 3, 5. Okay. Now again we'll be crashing activity 1, 2 and 3, 5 by 1 day. In ninth step of crashing, activity 1, 2 and 3, 5, or we'll just say crashing 1, 2 and 3, 5 again. Now the time will be from 22 to 21 days. 1 day will be reduced, and the corresponding cost will be 96,900 plus combined cost loop is 1350. 1350 minus 2000. 96,900 plus 1350 minus 2000. The cost loop is 96,250. 1, 2 and 3, 5 was crashed. We'll again update it in the network diagram. 6 will become 5. Here also 6 will become 5. Now here in case of 3, 5, normal duration and crash duration is same, 5, 5. So 3, 5 cannot be crashed further. Now 3, 5 is also out of the picture. Okay. Now if you update the table, again 1, 2 comes in first path, 1, 2 also comes in second path, 1, 2 also comes in third path, 3, 5 comes in fourth path, here it will be 21. Again 3, 5 comes in last path, here it will be 19. Now again critical paths are same and the duration is 21 days. Okay. Now we'll do one thing. In 10th step of crashing, I'll just write down the critical paths again, which are, we'll also mention over here, activity 3, 5 cannot be crashed further because in this step activity 3, 5 was exhausted. Okay. Critical paths are same again, and 3, 5 is out of the picture. Now to make it simple, I'll be writing all the paths again. Okay, 1, 2, 4 6 7 is the first path. 1 2 5 6 7 is the second critical path, and 1 3 5 6 7 is the third critical path. Okay, I will be writing down the independent activities as well. 1 2 2 4 4 6 6 7, again here 1 2 2 5 5 6 6 7, and for the last part 1 3 3 5 5 6 6 7. Okay, now if you see, activity 3 5 is out of the picture, 6 7 is already out of the picture. Okay, and activity 2 4 is also out of the picture. Now the remaining activities are activity 1 2, activity 4 6, activity 1 2 2 5 5 6, activity 1 3 and 5 6. Now we'll be making combinations again, just to keep it simple. We don't have to refer the previous step again and again. First will be first activity from first path, first activity from second path, first activity from last path. But activity 1 2 cannot be repeated. So first combination will only consist 1 2 and 1 3. Cost slope of 1 2 is 750. Cost slope of 1 3 is 2000. So the combined cost slope is 2750. Cost slope of 1 2. Now second combination 1 2 1 2 5 6, but 1 2 is repeated, so we'll just take 1 2 and 5 6. Here the cost slope is 750 plus 700, which is 1450. Now again, first activity from first path, second activity from second path, first activity from third path. Next combination will be 1 2 plus 2 5 plus 1 3. Cost slope of 1 2 is 750. Cost slope of 2 5 is 1000. Cost slope of 1 3 is 2000. 750 plus 1000 plus 2000 is 3750. Again, first activity from first path, second activity from second path, second activity from third path. Again the cost slope will be 750 plus 1000 plus 700. Here we get the combined cost slope as 2450. Now first set of combinations is over, that is 1 2. Set of 1 2 is over. Now the next will be first activity from first path, third activity from second path, first activity from last path. Cost slope of 1 2 is 750. Cost slope of 5 6 is 700. Cost slope of 1 3 is 2000. The second combination will now be first activity from first path, third activity from second path, second activity from last path, but 5 6 will be repeated, so here it will only be 750 plus 700. Combined cost slope is 1450. Now if you see, first set was of activity 1 2. Set of 1 2 is over. Next set will be of activity 4 6. Cost slope of 1 2 was 750. Cost slope of 4 6 is 1200. So if you think logically, there is no need to make combinations of 4 6. because it will definitely be greater than the combination of 1 2, which means that our minimum cost slope lies here itself, which is 1450, 1 2 5 6. Okay, so here crashing activity 1 2 and 5 6 by 1 day. Here the time will now be, in last step it was 21 days, now it will be 20 days, and the corresponding cost will be 96,250 plus combined cost slope is 1450 minus indirect cost per day is 2000. 96,250 plus 1450 minus 2000, we get the cost as 95,700. Again the cost is reduced from 96,250 to 95,700. I'll repeat this step again. We made the combinations of first activity from first path, which is 1 2. The cost slope of 1 2 is 750. Okay, now we, in last step, or we can say in the third step of crashing, where we made all the combinations, here it is not necessary to make all the combinations because cost slope of 4 6 is 1200. So obviously if we make the combinations of 4 6, the combined cost slopes of that combination will always be greater than this combination. So logically there is no need to make combinations of 4 6. Okay, that's why we took the minimum combined cost slope of this combination, which is 1450, and we crashed it by 1 day. Activity 1 2 and 5 6 was crashed by 1 day. We'll just update it in the network diagram. Okay, 1 2 was 5, now it will become 4. 5 6 was 4, now it will become 3. Now if you see over here, normal time and crash time of 1 2 is same, so activity 1 2 is exhausted, it cannot be crashed further. Now we'll also update the table of paths. 1 2 comes in first path, yes, duration will be 20. It comes in second path. 5 6 also comes in second path, here also it will become 20. Here 19 will become 18 because 1 2 is there. Here 5 6 is present, 21 will become 20. Here nothing is present, so this will be unchanged. Again the critical paths are same, the difference is activity 1 2 is exhausted. Okay, so in our 11th step of crashing, now the 11th step of crashing will definitely be the last step of crashing. Okay, if you ask me why, because in 10th step of crashing we got time as 20 days. In 11th step of crashing we'll be getting the time as 19 days, and if you refer this table, I have explained in the beginning that our crashing will start at 30 days, okay, and it will stop at 19 days. We have already reached 20 days, so in 10th step of crashing we have reached 20 days, so definitely the 11th step of crashing will be the last step of crashing. Okay, so I'll write it over here. 11th step of crashing, activity 1 2 cannot be crashed further, cannot be crashed further. Again I'll write down the paths. First critical path is 1 2 4 6 7. Second path is 1 2 5 6 7. Third path is 1 3 5 6 7. We'll write down the independent activities. 1 2 2 4 4 6 6 7. Here also 1 2 2 5 5 6 6 7. Here also 1 3 3 5 5 6 6 7. Now let's strike those activities which are out of the picture. 1 2 is exhausted, I strike it twice. 6 7 is also exhausted, here 1 2 will be exhausted. 6.7 is also exhausted. Activity 3.5 was also exhausted in previous steps. Activity 2.4 was also exhausted. So now the remaining activities are 4.6, 2.5, 5.6, 1.3 and 5.6. So now we'll be making the combinations. Here there will only be one set, which is 4.6. So our first combination will be 4.6 plus 2.5 plus 1.3. Second combination will be 4.6 plus 2.5 plus 5.6. Now we'll be taking the second activity, 5.6. Our third combination will be 4.6. Now we'll be taking second activity from second path, 5.6 plus first activity from third path will be 1.3. Again 4.6 and 5.6 will be same. Here 1.3, 5.6. Here will be 5.6, but it will be taken only once. Okay. Cost slope of 4.6 is 1200. Cost slope of 2.5 is 1000. Cost slope of 1.3 is 2000. Here the combined cost slope is 4200. Here again 1200 plus 1000 plus cost slope of 5.6 is 700. Here we get the combined cost slope as 2900. Here again cost slope of 4.6 is 1200. Cost slope of 5.6 is 700 plus cost slope of 1.3 is 2000. Here the combined cost slope will be 3900. In last step 5.6 was repeated, so we striked it once and we'll be taking the cost slope of 5.6 only one time. Cost slope of 4.6 is 1200 plus cost slope of 5.6 is 700. So the combined cost slope is 1900. Okay, all the combinations are over. Which is the least combination? This one, 1900 is the least combined cost slope, which is of activity 4.6 and 5.6. So here we'll be crashing 4.6 and 5.6 by 1 day. Now the time will be, in last step the time was 20 days, so now it will be 19 days. For 19 days the corresponding cost will be, total cost which we got in 10th step of crashing was 95,700. So here the total cost will be 95,700 plus combined cost slope is 1900 minus 2000, which is indirect cost of 1 day. So 95,700 plus 1900 minus 2000, we get the cost as 95,600. Again the cost was reduced by 100 rupees. Now the time is 19 days, and in the first step where we prepared the table, it was clear that the crashing will start at 30 days and it will stop at 19 days. Now even though there will be scope to crash the activities further, we will not be doing it because there is no way the total project can be completed in less than 9 days. So as 19 days duration is reached, we will stop our crashing process. Okay, 19 days is reached, we will stop our crashing process, and our final answer will be optimum duration is 19 days and the corresponding cost will be 95,600. This is our final answer. So that's all, friends. Now if you see, this problem was quite lengthy, but it covered all the aspects of crashing. It was necessary to make all the combinations and then choose. Please watch this video again if the steps are not clear, and try to solve this problem on your own. If this problem is clear to you, I assure you that you will be able to solve any problem of crashing without making any mistake. Okay. If there are any doubts regarding this problem, please let me know in the comment section. If you understood this video, like this video, share it with your friends and subscribe to my channel. Thank you for watching.